In this video, I'll be working through the Grade 11 KZN Term 1 2024 math paper. Now, as usual, we need to start off by solving for x, and 1.1.1, we've got 2x squared plus 5x is equal to 0. Now, looking at those two terms, we notice that they both have x in common, so we're going to start off by pulling out x as a common factor. So when we take out x from the first term, we're left with 2x. From the second term, minus 5, that is equal to 0. Now, once you factorize, you set each factor equal to 0. So we have x is equal to 0, or 2x minus 5 is equal to 0. Now, in the first factor, we've already solved for x. We see that it is 0. So we're going to work on the second factor, and let's take that negative 5 over to the right. It becomes positive. We're going to divide throughout by 2. So we have x is equal to 5 over 2. So those are our x values. This is quite simple. Now, looking at 1.1.2, we've got negative 4x squared plus 3x plus 6 equals 0. And in brackets, it says answer correct to 2 decimal places. So we know that for questions like this, where it says answer correct to 2 decimal places or answer correct to 1 decimal place, we know that these are questions where we have to use the quadratic formula to solve it, because we are going to get decimal answers. So it's not actually a trinomial that we can factorize on our own. So here's what we're given, and generally we make sure that the equation is in standard quadratic format. That is ax squared plus bx plus c is equal to 0. So here we see that a is negative 4, b is positive 3, and c is positive 6. Now, sometimes you may want to get your a value to be positive, where if you want to get rid of this negative, you can divide throughout by the negative. But it does not matter, because we can just take these values as we have it and plug it into our quadratic formula, and we will get the correct answers. So that's what I'm going to go ahead and do. So here is our quadratic formula, and substituting into this, we've got negative into b. b is 3, plus or minus the square root of 3 squared, minus 4. A is negative 4, c is positive 6, all over 2 into negative 4. Now, it's always good for you to simplify what you have before you actually get the values. So here we've got negative 3 plus or minus, let's see what's underneath the square root. So that is 105 all over negative 8. Now let's first work with the plus. So we get negative 0.905. But remember, they said that they want their answer correct to 2 decimal places. So it's going to be negative 0.91 when we round off. Then with the minus sign, we get x is equal to, it's 1.655, so it becomes 1.66. So these are the 2 answers to this question. Now going on to 1.1.3, we've got 3 square root x minus 2 is equal to x. And this is a typical grade 11 style question. Your aim here is to start off by isolating the surd, meaning that we want to get the surd alone. So here's what we can do. We can divide both sides by 3. So on the left-hand side, we're just left with the surd. And on the right-hand side, we have x over 3. Well, now that we have the surd alone, we want to get rid of the square root. So we are going to square both sides. On the left-hand side, the square root and the square cancel each other out, so we're left with x minus 2. On the right-hand side, we're going to have x squared over 9. Now to get rid of this 9 in the denominator, let's take it and multiply across. It's going to be 9 times x minus 2 is equal to x squared. Let's now take that 9 and multiply into the bracket. We'll have 9x minus 18 is equal to x squared. And what we notice here is that we are going to get a trinomial. But we need to try to get it in standard quadratic format. Seeing that our x squared term is positive and it's on the right-hand side, let's keep it on the right-hand side. Let's take all the other terms over to the right. So on the left, we're left with 0. And on the right, we have x squared minus 9x plus 18. Now this can be factorized, or you can use the quadratic formula to solve for x. But since it's quite basic, I'm going to go ahead and factorize. So to do so, we are going to look at factors of the last term. We have 1 and 18, 2 and 9, 3 and 6. And then we circle back to the same factors. So we are looking for factors that when we multiply them together, it will give us positive 18. But when we add them, we need to get negative 9. So the factors that will work out here would be 3 and 6. However, seeing that we need to add them together to get negative 9, we need to use a negative 3 and negative 6. So negative 3 times negative 6 gives you positive 18, and minus 3 minus 6 gives you minus 9. So that works out. So here's our brackets, x minus 3 and x minus 6. Now to solve for each bracket, we are going to equate each bracket to 0. So x minus 3 is equal to 0, or x minus 6 is equal to 0. And we get x is equal to positive 3, or x is equal to positive 6. Something important to remember is that when it comes to these questions where you've got a surd and you're solving for x, it is always necessary for you to check if both your x values work out. So we're going to take the 3 as well as the 6. We're going to substitute on the left-hand side, and it needs to equal to the right-hand side. So you can just do this on your calculator, but I'm actually going to write it down so we see what we're working with. Let's first try out 3. So we're going to have 3 into square root 3 minus 2. And remember, the right-hand side we have x as well, so we need this to equal to 3. We've got 3, square root 1 is equal to 3. Square root 1 is 1. So 3 times 1 is 3. And that is equal to the right-hand side. Now here's the thing. If it's equal, if the left-hand side and the right-hand side are equal to each other, then it means that that particular value is a solution. So the 3 works out. Let's now try 6. So we're going to have 3 square root 6 minus 2 is equal to, on the right hand side we have x, so we're going to substitute 6. Underneath the square root we have 4. Square root of 4 is 2. 3 times 2 is 6. So this works out as well. The left hand side is equal to the right hand side, which means that both of these answers are solutions to the question. We're now on to 1.2, and this is an inequality question. We have x squared minus x minus 20 is less than 0. And 1.2.1 wants us to solve for x for this inequality. So here's what we're given. And seeing that this is a basic trinomial, let's factorize this. So we are looking for factors of negative 20. That is going to be 1 and 20, 2 and 10, 4 and 5. And we are looking for factors that when we multiply them give us negative 20, but when we add them give us negative 1. So obviously the factors here that will work is 4 and 5, provided that we have positive 4 and negative 5. So positive 4 times negative 5 gives you negative 20, and 4 minus 5 gives you negative 1. So that works out. So when we factorize on the left, we have x plus 4, and in the other bracket, x minus 5. Now, here's the thing about working with inequalities. Even though we are solving for x, we are not allowed to say x is equal to. So nowhere in our working out are we allowed to have an equal to sign. That would be wrong, because this is not an equation, it's an inequality. So instead, the values that we would have x normally equal to in this equation, that is now known as our critical values. So from the first bracket, you would get x is equal to -4. And the second bracket, you would get x is equal to +5. Since these are inequalities and x is not actually equal to those values, we are not allowed to have an equal to sign. So instead, we take them as critical values. These are critical points in this equation. Now, since we're working with a less than, our answer is going to be written like this, where we have x lies between. We put the smaller value on the left and the bigger value on the right. And that is the answer. But this actually continued. There was a second part to this question. 1.2.2 says, hence or otherwise, determine the sum of all the integers satisfying this inequality. So what they actually want here is, based on the answer that you have, there are integers that satisfies this inequality, and we want the sum of those integers. So let's start off by figuring out exactly what values satisfy this inequality. Now, since you do not have, you've just got a less than signs, you don't have equal to's here. So this says that x lies between -4 and 5. So if we had to look at this on the number line, just to be able to visualize this, x lies between these values, meaning everything between -4 and 5. These are all the values that x represents. Actually, it's these values. These are all the values that x represents. So what they actually want is the sum of these values. So we're going to add -3 plus -2 plus -1. I just rewrote it to show the plus, +0, +1, +2, +3, +4. And they want to know what is the sum of this. So all you have to do is put this on your calculator, and the answer you get here is 4. So the sum of all the integers that satisfy this inequality is 4. We're now on 1.3, and we need to solve simultaneously for x and y. So here's what we have. And it is easier to work with the first equation. So let's do that. Let's make y the subject of the formula. We can take 4x over to the right. So we've got 7 minus 4x. Now that we know what y is equal to, we are going to take this value for y, 7x minus 4, and substitute in the second equation wherever we have y. So here's what we have once we substitute. Now let's simplify. So we can take this 2x and multiply into the bracket with both terms. We get 14x minus 8x squared. And on the right hand side, we've got a binomial squared. A binomial squared is always going to result in a trinomial. So we are going to get that trinomial, and let's actually do this using the short method. To get the first term, we square the first term, we have 49. To get the middle term, we multiply both terms together, and we multiply by 2. So if we multiply both terms together, we get -28x. Multiply that by 2, you get -56x. To get the third term, you square the second term. That is going to give you +16x squared. Now let's gather like terms. We can take everything over to the left. And when we do that, we've got 3x squared minus 8x squared, which is actually -5x squared. we can take the 16x squared over to the left. That is going to give you negative 21x squared. Gathering all of your terms with x in it, you're going to take this negative 56x over to the left. It will add onto the positive 14x. That is going to give you positive 70x. And you've got your constant 49, which goes over to the left and becomes negative 49. Now this is what we left. And to solve, what we can actually do is we can take all of these values as we have it, substitute into the quadratic formula, or you can simplify by noticing that every term can be divided by negative 7. So you can actually divide throughout by negative 7 and then factorize, but I think it's a lot easier here to just substitute your values into your quadratic formula. So I'm going to go ahead and do that. So here's what we have. The b value is 70, so we've got negative into 70 plus or minus the square root of 70 squared minus 4. The a value is negative 21, and the c value is negative 49, and then denominator 2 times negative 21. So once we solve, we get x as 7 over 3, or x is equal to 1. So these are our two x values, and now that we know what x is, we can take them and substitute into the previous equation where we have x. So I'm just going to write that underneath. So here is our substitution. Y would be 7 minus 4 into 7 over 3, or y is 7 minus 4 into 1. So here's our y values. Y is equal to negative 7 over 3, or y is equal to 3. So there we have it. We have solved simultaneously for x and y. Now 1.4 and 1.5 are actually tested on nature of roots. And 1.4 says the roots of a quadratic equation are, and basically what they've done is they've substituted values from a certain equation into the quadratic formula for you. And it says calculate the value or values of k for which the roots are equal. Now what we know is that when it comes to nature of roots, we work with the discriminant. And where is the discriminant located? The discriminant is actually located underneath the square root of your quadratic formula. So that is where it lies. So here, if you look at your quadratic formula, what's underneath it, underneath the square root, that is actually your discriminant. So looking at this given equation where it was substituted into the quadratic formula, what we have underneath the square root, that is actually your discriminant. So that's the first important thing. And the second thing is that they want to know for what values of k are the roots equal. So to answer this, let's start off by writing down a condition. So we're going to say for equal roots, and for equal roots, the discriminants must be equal to 0. Since we know what the discriminant is, it's what was underneath the square root, that was 13 minus 2k. Since that is the discriminant, that is going to equal to 0, and all we have to do from here is solve for k. So let's take 13 over to the right, it becomes negative 13. Divide throughout by negative 2 to get k alone. So negative 13 divided by negative 2 is going to be positive 13 over 2. So what does this mean? This means that this is the value of k when we substitute into that equation, 13 minus 2k. When we substitute in there, it causes the discriminant to be equal to 0, which means that we have equal roots. Now 1.5, given x plus 5 all squared is equal to 1 minus p squared. Calculate the values of p for which the roots of the equation are non-real. So now that's important. The roots of the equation need to be non-real. And notice here, you are given an equation. When you are given an equation and you notice that there is another variable where they commonly use p, what you have to do is expand, simplify, gather like terms, but get the equation in standard quadratic format. That is your first step. Okay, so let's do that. Now to simplify, let's get rid of that bracket on the left by expanding. So we know that a binomial squared is going to result in a trinomial that is going to give you x squared plus 10x plus 25. So how do we know this? To get the first term, we square the first term. To get the middle term, we multiply both terms together and then we times by 2. And to get the third term, we square the second term. Now on the right hand side, we had 1 minus p squared. Let's get everything over to the left. So we have x squared plus 10x. Taking the 1 over, we've got 24 because it minuses. Taking the minus p squared over, it becomes positive p squared. Now this is actually in standard quadratic format, where our a value here is 1. Remember, a is always the coefficient of x squared. Our b value is 10. And your c value is any terms at all that do not have x in it. So c here is the positive 24 plus p squared. It's both those terms. So this is your first step. Get the equation in standard quadratic format. Next, we are going to write down the condition. So we're going to say, for non-real roots, and remember here, for non-real roots, your discriminant is less than 0. So the discriminant, which is b squared minus 4ac, needs to be less than 0. Now we're just going to substitute. So b is 10, a is 1, c is 24 plus p squared. That is less than 0. Now let's simplify. 10 squared is 100. Negative 4 times 1 is negative 4. Multiply that by 24. That will be negative 96. And negative 4 times positive p squared is going to be negative 4p squared. Let's gather like terms. We've got 100 minus 96, which is 4. Now let's take the 4 over to the right-hand side. When it goes over, it becomes negative 4. To get p squared alone, we are going to divide throughout by negative 4. But here's the thing. With inequalities, whenever you're dividing throughout by a negative value, the sign changes. So this now becomes a greater than. And on the right-hand side, negative 4 divided by negative 4 is positive 1. To get p alone, we are going to square root both sides. And remember that when you square root a value, it gets a plus or minus in front. Now, what is p going to be? These are going to be our critical values. When we take the positive or negative square root of 1, that is going to give you positive 1 or negative 1. But how are we going to write out this answer? Since the question here, we ended up with a greater than sign. We have two separate answers. That means that x is less than the smaller value, or, well, actually p in this case, right? Or p is greater than the bigger value. So whenever you end up with a greater than sign, your answer is always, it's always two separate answers where the variable is less than the smaller value, or it is bigger than, or it's greater than the bigger value. So those are the answers to this question. Now we're on to question 2. And 2.1 says simplify fully without using a calculator. Your answer must be free of negative exponents and irrational denominators. So 2.1.1, we have 64 to the power negative 2 over 3. Let's start off by rewriting that base as a product of prime numbers. So 64 is actually 2 to the power 6. Now, whenever you are replacing a base with its product of prime numbers, we always replace it within a bracket. And if it had an existing exponent, that exponent goes outside the bracket. Now, to simplify this, we're going to apply laws of exponents. We're going to multiply the exponents together. So 6 times negative 2 over 3 gives you negative 4. But they had given you strict instructions that they don't want negative exponents. So how do we make this exponent positive? We take the base with its exponent and we put it in the denominator. Basically, we invert this. Now for 2.1.2, we've got 3 to the power 2n plus 2 minus 9 to the power n minus 1 over 2 times 3 to the power 2n plus 1. So here's what we're going to do. We need to start off by rewriting all of the bases as products of prime numbers. So everything else is fine besides this 9. So let us rewrite 9 as 3 squared. And I know I've mentioned this before, but just to mention it again, whenever you replace a base with its product of prime numbers, please replace it in a bracket. If it had an existing exponent, that goes outside the bracket. Now let's simplify. So where we have the bracket, we are going to multiply the exponents. That gives us 3 to the power 2n minus 2. Denominator is going to stay the same at the moment. Now, your bases in the numerator have more than one exponent on them. So I'm going to split them up. I'm going to write it as 3 to the power 2n times 3 squared minus 3 to the power 2n times 3 to the power negative 2. And I'm going to do the same thing in the denominator, 3 to the power 2n times 3 to the power 1. Now, why do we do this? Doing this allows you to identify terms that are common, or identify common factors in both your terms. So in both the terms, we have 3 to the power 2n, and we notice that it appears at the bottom as well. Now we're going to factorize the numerator. So let's pull out 3 to the power 2n at the top. In the first term, we're left with 3 squared. In the second term, we're left with minus 3 to the power negative 2. In the denominator, there's no need to actually factorize since we only have one term. Now that common factor is going to cancel out with itself in the denominator. So here's what we're left with. 3 squared is 9 minus 3 over negative 2 is 1 over 9. And 3 times 2 in the denominator is 6. So to simplify this, you can put the entire thing on your calculator. It will actually give you a simplified fraction that is going to be 40 over 27. That is your final answer. Now we're going to go on to 2.1.3, and this is based on surds, also based on rationalizing the denominator. So let's start off by rewriting what we're given. So here's what we have. And we need to simplify this numerator. So we've got a binomial squared. We know that it is going to result in a trinomial. To get the first term, we're going to square the first term. To get the middle term, we're going to multiply both terms together and times by 2. That is going to end up being a negative 6 square root 3. To get the third term, we're going to square that second term. That would be positive 3. Now in the denominator, I'm just going to leave this as we have it. Square root 3 times square root 6. Let us gather like terms at the top. So we've got 9 plus 3, which gives us 12, minus 6 square root 3, and denominator will leave as is. Now what we notice at the top is that our numerator 12 and 6 has 6 in common. So let's pull that out as a common factor. From 12 we're left with 2. From the second term we're just left with square root 3. Denominator stays the same. But normally when we factorize, we're able to cancel out our factor. However, the 6 and the square root 6 cannot cancel out just yet. But here's what we're going to do. To ensure that we get 6 in the denominator, we are going to rationalize. Now, when we rationalize, whatever we're trying to get rid of, or remember, the whole purpose of rationalizing is so that you no longer have that particular square root in the denominator. So we don't want square root 6. So to rationalize, we're going to multiply by square root 6 over square root 6. Now here's what happened. Multiplying in the numerator, I'm going to have 6 square root 6. So notice how I took the square root 6 and I've multiplied with the 6 in front. The bracket stays as is. The denominator, I'm going to have square root 3. But what happens when we take square root 6 times square root 6? It gives us 6. And at this point, here's what happens. The 6 from the numerator and the 6 from the denominator cancel out with each other. But what can we do to simplify the square root 6 over the square root 3? There is this rule that says square root a over square root b is the same thing as a big square root of a over b. So if both your numerator and your denominator has a square root, ultimately you can write one big square root with the fraction underneath. So if we apply this to square root 6 over square root 3, it's the same thing as the square root of 6 over 3, which actually simplifies to 2. So this part is the same thing as square root 2. So we've got square root 2, and the bracket is 2 minus square root 3. And here's what we're going to do. We're going to take the square root 2 and multiply into the bracket with both terms. Square root 2 times 2 is 2 square root 2. And for the next part, square root 2 times square root 3, there is this rule that says square root a times square root b is equal to the square root of a times b. So applying that to what we have, square root 2 times square root 3 is the same thing as the square root of 2 times 3, which essentially gives you square root 6. So your second term here is going to be square root 6. Now this cannot be further simplified, which means that it is your final answer. Now 2.2 is based on solving for x without using a calculator. So for 2.2.1, we've got the x root of 32 is equal to 128. So this is what we have. And what can we do? How can we rewrite this? So we learned in grade 11 that surd, any surd, can be converted to a fraction. Specifically, a rational fraction. What does a rational fraction mean? A rational fraction means, or a rational exponent actually. A rational exponent means a fraction. Basically, we're going to rewrite this as 32 to the power of, and we're having an exponent that is a fraction. Now how this works is, the exponent that was on the base goes in the numerator. So here it was just 32 on its own, which means that its exponent was 1. And the degree of the surd goes in the denominator. So here's how we're starting off. We rewrote the surd as a rational exponent. In the next step, I'm going to rewrite these bases as products of prime numbers. So 32 is the same thing as 2 to the power 5, and 128 is 2 to the power 7. Now on the left hand side, to get rid of the bracket, let's multiply the exponents. 5 times 1 over x is going to be 5 over x. On the right, we have 2 to the power 7. Now remember that when you have x as an exponent and you need to solve for it, your aim is to get the bases to be the same. Once the bases are the same, they cancel out with each other and we equate the exponents. So we have 5 over x is equal to 7, and through cross multiplying, we see that x is equal to 5 over 7. So remember that the good thing about solving for x is that you can always check if your answer is correct. All you have to do is take your value of x, substitute into the equation wherever you see x. So here we have it as the degree of the surd, and you should get the right hand side as your answer. Now looking at 2.2.2, we've got x to the power half minus 3 times x to the power 1 over 4 minus 10 is equal to 0. Just by looking at this question, there's something that should be quite clear to you of what you need to use. That is the K method. It's necessary for us to use the K method here to solve for x, and if the K method is something that you're struggling with, I have covered quite a few questions in previous videos on the K method where we explored all the different ways and all the different types of equations that require you to use the K method. This is just one of them. So if you're not sure about what the other type of equations are that require the K method, then please make sure you check out those videos as well. The K method is an extremely important concept in grade 11, and there will definitely be a question testing you on this in your exam, because this is part of the concepts that you needed to learn in term 1. So how does the K method work? Now we look at these exponents that we have of x, and they are rational, so they are fractions. We're going to start off by letting k equal to x with the smaller exponent. So here is x with the smaller exponent. Obviously 1 over 4 is smaller than 1 over 2. So we start off by saying let k equal to x to the power 1 over 4. Now the next step is to rewrite this entire equation in terms of k. So your first term automatically becomes k squared. Second term is now minus 3k. Constant stays the same, negative 10. Now in case you're wondering, why is it that your first term automatically becomes k squared? I'm just going to show this to you on the side so you understand where this is coming from. K squared is the same thing as k times k. Right, anything squared means that it's being multiplied by itself. Since we chose k as x to the power 1 over 4, we have x to the power 1 over 4 multiplied by itself. According to laws of exponents, when we are multiplying bases that are the same, we add the exponents. 1 over 4 plus 1 over 4 gives you 1 over 2. And you can see that this 1 over 2 is the same thing as your first term, which is equal to k squared. But obviously, it's not necessary for you to show why it's k squared. This on the right hand side is just for your understanding. Also, what is the purpose of the K method? So the K method is used to convert trinomials into standard quadratic format. Here we have a trinomial, but it is not, we cannot call it a quadratic trinomial, because a quadratic trinomial has to be of the form ax squared plus bx plus c. But now because we have it in terms of k, we have a k squared plus bk plus c. Now the whole aim of getting it to be in quadratic format is that it allows you to simplify a lot easily, where you can either factorize on your own or you can use a quadratic formula. But since this is quite simple, I'm going to factorize Factors of 10 I'm going to take as 2 and 5. When I multiply them, I need to get negative 10. But when I add them, I need to get negative 3. So I should take a positive 2 and a negative 5. Now, equating each bracket equal to 0 and solving for k, you will have k is equal to 2, actually negative 2, or k is equal to positive 5. Now, here's the thing. The k method is something that you use to simplify your equation. But the given equation did not have k in it, it had x. And the question specifically said, solve for x. So what you have to do is, once you've solved for k, you need to replace k with what it was initially equal to. So on the left-hand side, we're going to have x to the power 1 over 4 is equal to negative 2. And the same thing for the second equation. X to the power 1 over 4 is equal to 5. Now we're going to work towards solving for x. So to get x alone, we want to get rid of this exponent 1 over 4. And how we do that is we multiply that exponent by its inverse. The inverse of 1 over 4 is 4 over 1, which we can just take as 4. And what we do on one side of the equation, we must do on the other side as well. We're going to apply this to both equations so that we can get x alone on the left-hand side. Now on the left, we have x is equal to 16. And on the right, we have x is equal to 625. So remember, for questions like this where you use the k method, it's always important for you to take your values of x and substitute back to see if they work. Now when you take 16 and you substitute in place of x, remember your left-hand side needs to equal to the right-hand side. So go ahead, put it on your calculator. But you see that when you press equal to, it does not give you 0. We need it to equal to 0 so that it's equal to the right-hand side. Since it does not equal to 0, it means that this is not part of the answer. So what we do is we write down not applicable. And next one, try 625. So substituting 625 into the left does work out. You do get 0 on the right-hand side. So you can underline x is equal to 625 as your answer. So always make sure that you check these values because it is not all the time that both of them actually work out. And if one of them don't, then it's important for you to indicate that. Question 3 is based on trig. So it says, do not use a calculator when answering question 3. 3.1. In the diagram below, point P is negative 6 and 8. That is a point in the Cartesian plane. A is a point on the positive x-axis, where angle AOP is equal to theta. Determine with the aid of a diagram the following. Now, the diagram that they're talking about obviously is a triangle. We are in the second quadrant, so we know according to the butterfly diagram, this is what the orientation of the triangle is going to be. So that's what it should look like. Now, based on the information that's given, you have a point. And remember, a point is made up of an x value and a y value. Your x value represents the horizontal distance, and the y value represents the vertical distance. So right now on this diagram, we have two sides of the triangle. And before we can answer any of the questions, we need to make sure that we have all three sides, and to do that, we can use the theorem of Pythagoras. But also, if you look at 3.1.1, that is the first question. The hypotenuse here is OP, because it goes from the origin up to point P, so they're calling it OP, and they want the length. So we're going to use theorem of Pythagoras to answer that. So 3.1.1, that is r squared is equal to x squared plus y squared. Now when we substitute, I'm just going to replace r with OP because that is its proper name. X is the horizontal distance, which was -6. Y was the vertical distance, which was 8. Now, since you're solving for OP and you need to get rid of the square, we're going to square root both sides. So on the left, we have OP, and on the right-hand side, when we calculate this, you get 10. Now remember, OP, which is the hypotenuse, is representing a length, so it's actually going to be 10 units. So that we can actually fill in on the diagram. So here we have 10. Now for 3.1.2, we need sine theta plus cos theta. So to get these values, we are going to refer to the diagram. Let's start off with sine theta. In terms of theta, sine is opposite over hypotenuse. So that is going to be 8/10. Cos is adjacent over hypotenuse. That is going to be -6/10. Now here's the thing, right? The question says do this without using your calculator. But when it comes to steps like simplifying your answer, you can use your calculator to do that. So to simplify these fractions to get the final answer, putting it on the calculator, we get 1/5. So that is the answer. We're now looking at 3.2. It says if sine 25 degrees is equal to 1/k, determine the value of tan 25 degrees in terms of k. Now questions like this where we've got the angle, we have the fraction, and we see that there's an unknown like k here, we know that we have to use a triangle to help us out as well. So here's what we're given, right? And to draw a triangle to match this, your triangle is going to be in the first quadrant. And how we know it's going to be in the first quadrant is because our angle is 25 degrees. So 25 degrees definitely has to lie in the first quadrant. Just want to draw this triangle a little better. So that is slightly better. It's a right angle triangle. Here we have 25 degrees, and in terms of that, we're going to fill in what we have for our fraction. So remember, sine is opposite over hypotenuse. So here, your numerator is 1. So that is the opposite side. And the denominator represents hypotenuse. So the hypotenuse is k. Now we're going to use the theorem of Pythagoras so that we can solve for the unknown side. So hypotenuse is k, that's going to be k squared. It is the horizontal part of the triangle that's unknown, which is x. And y is the vertical part, which is 1. 1 squared is 1. Let's get x squared alone on the right-hand side by taking the 1 over to the left. And lastly, to get x alone, we're going to square root both sides. So x is equal to the square root of k squared minus 1. So that is what you're going to have as your horizontal distance on the triangle. Now we can actually answer the question. They wanted tan 25 degrees. So in terms of our triangle, remember tan is opposite over hypotenuse. That is going to be 1 over the square root of k squared minus 1. That is your final answer. For 3.3, we are required to simplify the following expression without the use of a calculator. Let's just start off by rewriting this. So here's what we have. And we're going to work part by part. So the first part we're looking at is sine 698 degrees. What we notice here is that the angle is bigger than 360. Whenever you're given an angle bigger than 360, you need to minus 360 from it. So if we take that, 698 minus 360, we get 310. and 38. So if the angle is smaller than 360, we can work with it because we can apply reduction formula to it. So at the moment, all we did is we reduced this. Next, we're focusing on cos 300, and cos 300 lies in the fourth quadrant, so we can reduce that using 360 minus 60 degrees. In the denominator, we have tan 135. 135 lies in the second quadrant, where we're going to use 180 minus. That'll be 180 minus 45 degrees. Next, we have cos of a negative angle. Cos of a negative angle is positive cos of that angle. In the next step, I'm going to simplify that sine 338. 338 lies in the fourth quadrant. So let's use 360 minus, and that's going to be 360 minus 22 degrees. Next to that, we have cos of 360 minus 60. 360 minus lies in the fourth quadrant where cos is positive, so that just becomes positive cos 60 degrees. Then focusing on tan 180 minus. 180 minus lies in the second quadrant where tan is negative. So that becomes negative tan 45. And what about cos 248? That is not simplified. That is not reduced. So let's further reduce that. 248 lies in the second quadrant. So let's use cos of 180 plus. That's actually going to be 180 plus 68 degrees. Now further simplifying, in our numerator, we have sine of 360 minus 22. 360 minus lies in the fourth quadrant where sine is negative. So it becomes negative sine 22. I'll leave the cos 60 as is for now because we notice that is special angles, as well as negative tan 45. That's another special angle. Now reducing here, cos of 180 plus. 180 plus lies in the third quadrant where cos is negative. So it becomes negative cos 68. But here's the thing, right? When you do these questions and you have angles that are not special angles, like the 22 and the 68, they are related to each other. We need to try as much as we can to get them to be the same. So what I am going to do is, I'll keep the numerator as is. But in my denominator, I am going to further reduce cos 68. And I'm going to write that as cos of 90 minus 22. Because remember, 68 degrees is an acute angle. So it is in your first quadrant. But now, this is good because when we reduce it, we notice that we have 90 minus 22. And we have 22 at the top. So that's what I mean when I say that angles that are not special angles, they'll be related to each other, where eventually, through reduction formula, you can get them to be the same. Now, keeping the numerator as is, and just simplifying here in the denominator, 90 minus is in the first quadrant where all our trig ratios are positive. However, cos paired with 90 becomes sine. So we have negative sine 22. Now what we notice here is that the sine 22, the negative sine 22 from the top and the negative sine 22 from the bottom cancel out with each other. Now we're just left with special angles and we can substitute their values. Cos 60 degrees is 1 over 2. Then we have a negative, and tan 45 is just 1 over 1, which is 1. So a half divided by negative 1 is negative a half. And that cannot be further simplified, so that is your answer. Now we're on to question 4, and 4.1 says simplify the following expression fully. So here's what we have, and just by looking at it, we notice that we're given reduction formula. So we've got sine of 180 plus x times sine of 90 plus x. We also have negative angle, so tan of minus x. And on the right hand side, reduction formula as well. This is for 7 marks. Now these kind of questions where you need to simplify test you on all your knowledge of trig. So make sure you have a good understanding of reduction formula, of special angles like the previous question that we did, negative angles as well, and the cast diagram so that you're able to know in which quadrants which trig ratios are positive. So let's start off by rewriting this question. So here's what we have. And in the first equation, we're starting off by focusing on sine 180 plus x. Now firstly, 180 plus lies in the third quadrant where sine is negative. So that becomes negative sine x. Now focusing on sine 90 plus x. 90 plus lies in the second quadrant where sine is positive. However, sine paired with 90 becomes cos. So that becomes cos x. In the denominator, we've got tan of a negative angle, which is minus tan of that angle. Next to that, we've got plus sine x. And then we have cos of 90 minus x. 90 minus is in the first quadrant where all our trig ratios are positive. However, 90 minus changes cos into sine. So that becomes sine x. Now to simplify, in our first equation, both our numerator and our denominator are negative. So the negatives can fall away because negative divided by negative is a positive. So the negatives are gone, but everything else in the numerator will stay as is. In the denominator though, we have tan x. So we know that tan is sine over cos. So let's replace that. In the second term, we've got sine x times sine x. That is going to give you sine squared x. And I just want to show you something on the side. If we focus on this first fraction, we've got sine x, cos x. And to show you what happens here, I'm just going to replace the main division line or the main fraction line with a division sign. So the numerator is being divided by sine x over cos x. Now you learned in primary school that when you are dividing two fractions together, your next step is to change the division into a multiplication and your second fraction gets swapped around. So that becomes cos over sine. At this point, you are allowed to cross cancel. If any of your numerators and denominators are the same, they cancel out. So we notice that we've got sine x in the denominator as well as the numerator here. They cancel out. So here, the sine x cancels out. And what we're left with is cos x times cos x. That is going to result in cos squared x. So we're left with cos squared x plus sine squared x. And this actually comes from your identity. The identity actually has it the other way around. Sine squared x plus cos squared x is equal to 1. So your final answer for this question is 1. Now 4.2, we are given sine theta over 1 plus cos theta. And it says, prove that sine theta over 1 plus cos theta is equal to 1 minus cos theta over sine theta. So here's what we gotta do. This is the type of question where we are proving left-hand side is equal to right-hand side. So here we're going to start off by saying left-hand side is equal to, and looking at, if we go back up to the question, and if we analyze the right-hand side, the answer that they want is kind of this fraction inverted, but the sign changed. So we got the sine theta at the bottom, and in the numerator we have 1 minus cos theta. So a good question is, how are we going to invert this? What are we going to do to now end up with the sine theta at the bottom? Now, one way to get 1 minus cos theta in the numerator is to multiply this fraction by 1 minus cos theta over 1 minus cos theta. So why are we allowed to do this, and where is this coming from? The reason why we're doing this, firstly, is that we need to get 1 minus cos theta at the top, okay? And there's no way, at the moment, there is absolutely no way for you to simplify this given fraction, because it is in its simplest form. We can't do anything else. So the only way for us to introduce 1 minus cos theta is if we multiply this fraction by 1 minus cos theta over itself. So to answer the second question, why are we allowed to do this? In maths, if you take a particular fraction and you multiply by 1, for example, say that we're taking the sine theta over 1 plus cos theta and we're multiplying it by 1. Multiplying by 1 has no effect on the fraction. It is still sine theta over 1 plus cos theta. So this fraction that we're multiplying by essentially is 1, because any value over itself is 1. For example, if you take 5 over 5, it's 1. Likewise, the fraction that we're multiplying with here, because it is over itself, essentially it is 1. So we are allowed to do this. So when we are multiplying two fractions together, we multiply the numerators together and we multiply the denominators together. Now, I'm not going to do anything with the numerator. I'm going to leave it as is. Sine theta into 1 minus cos theta. But I'm going to expand the denominator. So we're going to use a FOIL method. We've got binomial times binomial. We're going to have 1 times 1, which is 1. 1 times negative cos theta is negative cos theta. Positive cos theta times 1 is positive cos theta. And positive cos theta times negative cos theta is negative cos squared theta. Here we notice that we got negative cos theta, positive cos theta, they cancel out. So here's what we're left with. But we need the denominator to be sine theta. How are we going to get sine out of 1 minus cos squared theta? Now remember your identity. Your identity is sine squared theta plus cos squared theta is equal to 1. However, if you manipulate this by taking the cos squared theta over to the right, it becomes negative cos squared theta. Notice what you now have on the right hand side matches the denominator, which means that the denominator is actually equal to sine squared theta. So let's replace the denominator with that. So here's what we have. We've replaced the denominator with sine squared theta. And now what happens is the sine theta from the numerator cancels out with 1 of the sine theta from the bottom. So what we're now left with is 1. And this, okay, I just realized this was actually a mistake, right? So this is supposed to be 1 minus cos theta, not cos squared theta. Okay, so in the numerator, we are left with 1 minus cos theta, in the denominator, sine theta. So this is equal to the right-hand side. That is actually what they wanted. Now, question 4.2.2 says, for which value of theta in the interval 0 to 360 is this equation, or is this fraction, sine theta over 1 plus cos theta undefined? Now, a good question to ask yourself is, generally, when is a fraction undefined? A fraction is undefined when the denominator is equal to 0. We need to know, when is this denominator equal to 0? because whatever those values of theta are, when we substitute them, it makes this fraction equal to 0. So all we have to do for questions like this is simply take that denominator and equate it to 0. That's exactly what you do. And we need to solve for theta, so we're going to have cos theta is equal to, taking the 1 over to the right, it becomes -1. And to get theta alone, let's take cos to the right hand side, be cos to the -1 of a -1. And theta ends up being 180 degrees. Now what this means is, in this fraction, if we substitute 180 degrees, and you can try it out on your calculator, so you'll have sine 180 over 1 plus cos 180, you would get math error on your calculator, meaning that it is undefined. So that is what we actually wanted to calculate. We wanted to know the value of theta that, when we substituted, made the fraction undefined, and the value of theta had to lie between 0 and 360. So that brings us to the end of this paper. So this paper was out of 75 marks in total, and it was written over 1.5 hours. Please remember to like, subscribe, and turn on your notifications for more content.